My name is Sayjesh. I am a behavioral ecologist. I uh, I study in this group of bees called the giant honeybees. So what when I say honeybees, the first thing that probably comes to your mind would be bees that the Western honeybees, which are usually kept in boxes, and so that is one kind of honeybees. But there are a lot of honeybees out in the tropics. Some of them who similar to the Western honeybees, they nest inside boxes or inside cavities, and some which nest out in the open, like the bees that I study, which is known as the giant honeybees or Apis dorsata. And these bees, unlike the ones that are found in boxes, they just nest on one comb. So the entire colony, which can consist of upwards of 20,000, 40,000 bees at some points of time, they nest out in the open on one single comb. They also have some unique behavioral features that enable them to uh, kind of deter predators, because it's a very easy target if you consider, right? It's like one very prominent structure out in the open, and as you might imagine, it attracts a lot of predators. So one thing they have, they're extremely aggressive, so that should keep away a lot of predators. But then there are also some other behavioral adaptations that they show, which kind of where they don't really have to engage with the predators themselves. Our experimental technique is fairly simple. We just have a very uniform background which we place in front of the hive, and we just move uh, an object. It's a circular disc basically in front of this hive against this background. Now, other studies, or there's one other study which has moved a much larger object in front of the colony. And in that study, what they have seen is that the bees actually turn aggressive. They chase this object, they start stinging the object. In our study, they don't really do that because the size is smaller. So there seems to be a threshold size at which they go from this shimmering wave like response to a very aggressive response. Which, again, if you consider a predator, this can either be like if a predator is really small or if it is far away, they might resort to just using a shimmering response to distract the predator. But once it goes beyond a specific size, or once they become really close, that is probably when they start stinging the predator, which should, ideally keep them away. So there are certain areas on the bee curtain which seems to be more sensitive to predators or intruders, and the shimmering response usually starts from these regions, or there are some regions from where there is a higher probability of the shimmering response to start. But once it starts, it usually follows very simple physical properties uh, to transmit across the comb. So just based on very local phenomenon, like for instance, the force that is being generated by your neighbors, other bees get triggered into performing this behavior, and it propagates along the surface in that manner. And there are also some regions which tend to accelerate this wave, so it need not necessarily travel at the same speed throughout the bee curtain. Some areas or some bees are able to detect this oncoming wave from a greater distance, which kind of accelerates this wave propagation. So I was not really, primed towards ecology during my undergrad, but then I had this course which we have at our institute, which is called IISER, uh, and the course kind of gave us a hands-on project, uh, and gave us this opportunity to design our own experiments, and then uh, observe animals, and then record our findings, and then present it, right? So this gave me a taste of this whole idea of the process of science, not just disjointed disconnected experimental techniques, but then using these techniques in a very holistic manner from start to end. And this happened fairly early on during my scientific career, and this kind of turned me towards animal behavior specifically. And back then, I was looking at these spiders which mimic ants, and that's a very fascinating mimicry going on there.